Well, hello, everybody. Good morning, good afternoon, good evening, maybe good night to everyone, wherever you may be across our lovely world. Thanks for joining us live here today for the one and only Serverless Office Hours. We are streaming on the AWS Twitch channel and also on the Serverless, on also YouTube via the AWS Events channel. I'm Julian. I'm a developer advocate for mainly serverless here at AWS, but we do a bunch of things. And I'm super happy to have one of our guru, OG, I think, developer advocates, Sebastien, welcome to Serverless Office Hours.
Thank you, Julian.
Bad on me that we haven't had you before, but people who don't know Sebastien, what's your journey to AWS? And I think you've been around for a while and we've done some cool stuff.
Yeah, I'm a developer advocate as well. So just to let you how it works at AWS, Julian and me, we are on the same team, at least since a year or two, since the last reorganization. My goal is to go and to meet developer at conference or similar types of events and to talk about AWS, to demo, to show, to make it easier to get started with AWS and to use the AWS cloud. As you might have noticed, I have a slight touch of French accent, so I'm working a lot with French-speaking communities in Belgium, Luxembourg, France, Switzerland, North Africa, Central Africa as well. And I'm working a lot with a developer. I call them Apple developer, but it's the developer developing for Apple platform, iOS, macOS, iPadOS, visionOS, and all the OSs from Apple.
Cool. Yeah, I think it's an awesome story of the whole sort of Apple ecosystem. It's actually, I mean, I use an iPhone, but I actually use Windows. So I'm sort of mixing on both. And yeah, it's amazing how big the sort of Apple ecosystem is, obviously, with all the stuff that's going on. And yeah, so we're going to be talking today about some, super cool Swift kind of stuff. But you're already famous because we already have Jeff in the comments. Thanks for joining us by YouTube saying, welcome,
hello,
Sebastien. Jeff. And schizophrenic web developer joins us often. Always welcome back via Twitch. Sebastien from France. That was even before you said France. So
I'm from Belgium actually, but I live in France,
exactly,
which is confusing because it's the same language of the country. Don't hesitate to drop a note in the chat, in the comment, to tell us where you are, from which city you are listening or watching this live stream. I love to see all the different places, so throw them in.
Seb is the ultimate pro because we always ask that. We have such a global audience, and it is cool to see where everybody is from. And we're not going to get on the. We don't need. Well, we can always have some comments on what is Belgium versus France, and if we're talking mille frites or other kind of things that are going to compete across the border, or which beers we prefer.
Chocolate, French fries.
Chocolate, and Tintin, and all the cool Belgian things as well. So so we have Grant Lammy, who's a great friend of Serverless Office Hours. Thanks for joining us again from the People's Republic of Ohio. We have
US East one. That's a good one too.
Cole, Tennessee. Voodoo Dali's joining us, not in France or Belgium. I agree, I'm not there either. We have LRX joining us via YouTube, US East 1. Hopefully everything's working for you today at the moment. Don't blame DNS. Sally on our team as well, wanting to also learn from the masters.
Hello,
I'm
Sally.
doing with Sebastian's beard game is strong. So
yeah, that's an experiment I'm making. I don't usually have a bird. It's just a test. It's an experiment. It will probably not survive the end of the year, but here it is for today.
We like it. And Jeff replying, Ohio is US East 2. And we also have Voodoo Dali, who's clarifying. He said not in France or Belgium, but the People's Republic of Ohio too. So Voodoo Dali and Grant Lammy may be next door neighbors. Who knows? But yeah, lots of stuff over the world. Please let us know. Remember, we are live. This is the advantage of doing Office Hours live. So send us your questions, send us your comments, and we'll try the best to answer them. Well, Seb will try his best to answer them, and I will just nod lightly because Seb knows everything that we're talking about. But today we're talking about Swift, and I love it. Swift server-side serverless, great alliteration, a hitchhiker's guide. So Seb, just set us off here. What are we talking about? I know that Swift is from a developer platform programming language for Apple kind of devices, but that's probably where my knowledge goes. I know it's good. I know people like it. I know it's fast, blah, blah, blah. But yeah, so give us a sort of picture of what you're talking about about Swift.
Yeah, the idea is to use the Swift programming language on the server side. And when I say that, most people say, what? Wait, Swift? Swift is the Apple things for iPhone, but you can use that on the server as well. And yes, you can use on the server. I will show you how. I will try to explain you why. And I hope at the end of the session, you want to try Swift and Swift on the server. I have just like 10 slides or something like that to get started, to put the context. And then I will switch to a code editor. And the rest of the session will be live coding. So it will be really hands-on, live. I have a script. I will do some copy paste because some comments are a bit long sometimes, but I will show you different ways to create Lambda function in the Swift programming language. It's for me, it started like a side project a couple of years ago. And then there were multiple Swift runtime at the moment that AWS announced the possibility to create custom runtimes, and one of them was sponsored by Apple, so they all like converged to that one. I'm now the maintainer for the Swift Lambda runtime. I will show you that. I will explain how you can use that in your project and why you should use it. So please ask question, drop your question. Julian, I don't have the screen, the video screen in front of me, so don't hesitate to interrupt when I stop talking. I know it's rare, but I will stop talking to take question and to answer a question as well. So for those of you that don't know, Swift is a programming language. It's a general purpose programming language that has been invented, or first release at least, 10 years ago already. So it's 10 years old. It's not a new technology. 10 years, it's quite a lot, even for a programming language. It was originally designed by Apple as a replacement for Objective-C for all their platforms. So this is the programming language if you want to develop an Apple application today, at least what we call native development. Because, you know, certainly, I know Sally is one of our listeners tonight, there are cross-platform alternatives as well. But if you go native, Swift is the way to go for macOS, for Vision OS, for watchOS, for all the OSs from Apple. But not only, because Swift has also a compiler on Linux and on Windows. And even recently, they launched Swift for Android. And I can take a few questions.
Yeah, Sally actually did do a comment about that. Now you can build Android apps as well. So that is awesome.
That's correct. So to be clear, they don't port Jetpack, so the graphical user interface framework to align components, graphical components on the screen. But at least you can have a shared library with the common data structure, code to access your backend, business logic written in one programming language, Swift, for example, and share that library across your two applications. So just the UI, Jetpack on Android and Swift UI on iOS would be different, but you can have the same a shared library between your application. Swift is quite easy to understand, easy to start with, at least for doing something simple. It's simple. If you want to do something a bit more complicated, it might become a bit more complicated. I guess it's like all language, but it's very familiar. If you are used to develop in Java, in C#, you will feel at home almost directly. You can create structure, classes, protocols. Protocol is like an interface in Java. You can create objects. You have support for JSON encoding, decoding, printing, debugging. You can compile from the command line or from an IDE. There is support, of course, from Xcode, which is the IDE from Apple, but there is a really good plugin for Visual Studio Code and all the Visual Studio Code family IDE as well. So why Swift on the server side? Actually, there are a couple of key characteristic in this language that make it quite good for server-side application. First, it's compiled, so it creates a binary, which is quite efficient. It's more efficient than bringing a virtual machine with you, like Python or JavaScript or Java, for example. It's a real binary compile for your platform. It has extremely good memory management, so there is no garbage collector, so there is no pause, so you have a predictable execution time, at least as far as memory management is concerned. It's strongly typed, which is a quality I love. So that's why I use TypeScript over JavaScript. That's why I use Swift over Python. Python, for example, because the compiler can catch a lot of bugs for you, but just by checking the types that you're exchanging between the different parts of your code. The compiler is also really good at catching a race condition or possible race condition. So to detect if you are exchanging mutable state, like variable, in between two different, what they call isolation contexts, basically two different threads. So if you're sending data from one thread to the other, the compiler will block you saying, hey, this is not safe, you should not do that. And then you can apply a bit of syntax magic to make the compiler happy if you're absolutely sure about what you know, or you have to change the logic of your code to not exchange mutable states, variable. So good at memory, efficient in terms of performance, strong typing, very strong protection against concurrency error. All these characteristics made Swift a really good programming language for the server side, especially for Lambda and serverless, where it's important to have a small binary that consume not too much memory, because you will be able to use a smaller Lambda runtime environment, which will reduce also your cost. So you can use Swift on the server to write scripts. There is a lot of customers that are using it to write API and deploying on Docker, on any type of container management system, business process, CLI as well. There are two web frameworks, an older one called Vapor and a more recent one, more modern, called Hummingbird. So you have choice. These are web frameworks that allows you to create a web application or to create a web API, for example, a bit like Express in JavaScript, TypeScript, or the other web frameworks you are used to using into your application. And there is a large ecosystems and a really vibrant community of developers. So they have package for OpenTelemetry, for gRPC, for Prometheus. Apple is publishing Docker image, so you can just get a Docker image, Docker pull Swift or Swift colon 6.2, 6.1, the version that you want, including the nightly build for the next version of Swift. So it's extremely easy to get started with containers. They have some low-level libraries as well, like a Neo library. I forgot the name for that in Java, but it's a non-blocking IO library on top of which most of the other networking libraries are built. They have driver for Postgres, for MySQL, for MongoDB, more recently from Valkey. There are really good asynchronous HTTP clients. We are working on an HTTP server. There are generators of code from an open API definition. So all the tool chain and the libraries and the context to start to write your server-side application is there today. And as just like yesterday, AWS released Swift on Amazon Linux as well. So now if you start an EC2 instance on Amazon Linux, Swift 6.2 is available. It's not pre-installed. It's available in the package repository. So you can just type sudo dnf install SwiftLang, and a minute later you have the Swift toolchain, so you can start compiling, building, or running your Swift executable on Amazon Linux. There is no Docker container from Swift.org yet, but they are working on that. It's public, so I can say it. The CI chains are already in place. You can see the status of the CI chain for the Docker container, and they're built. So I hope it will arrive soon as well. In the meantime, you can create your own Docker container with your own Docker file. You start from the Amazon Linux 2023 base image, and you just DNF install SwiftLang. And by the way, this is only needed if you want to compile and to build your application. Once you have a binary, it can be run on Amazon Linux without any special library needed to be installed. Just glibc is enough.
Cool. So, and I suppose because Lambda uses, well, you can choose to run an OS-only runtime for Amazon Linux 2023. You can actually have some consistency in your building or tooling or whatever, that you can just run an EC2 instance. Yeah, in serverless, sometimes people do run EC2 instances to do things. But yeah, off you can go. You can build your binary anywhere, or of course you can do it on your workstation as well. So yeah, I like it.
There is a question there. I see is Swift a multi-paradigm programming language? I'm not sure what you mean by multi-paradigm. If you mean object-oriented, functional, yes. The answer is you have the concept of class, of inheritance. If you want to do object-oriented programming, you have a function as first-class citizen. So if you want to pass a function as an argument and chain functions like that, you can do that as well. Yes, so it's multi-programming, and yes, it's available for x64 and ARM64 for Amazon Linux, I guess. Jeff, the question is, I guess for Amazon Linux, yes. And in general, yes. Actually, it's even more because there is a Swift support for embedded device as well. I'm not going to talk about that today, but for embedded developers, small controllers, you can run Swift there as well. And that's almost the end of my slide. So given all these qualities of that programming language, when we first release the ability to create a custom runtime for Lambda, I say, hey, I have to try to write a Swift function in Lambda. And there is if you are not familiar with custom runtime for Lambda, it's a mechanism that allows you as a developer to write your Lambda function in any programming language. So you know that by default, you have JavaScript, TypeScript, you have Go, you have Python, you have Java. I will not give the whole list. Maybe you know it by heart, Julian. I don't. I will certainly miss one or two, but there is like 7 or 8 or something like that that are supported and provided by AWS. But actually, you can write handler code, you can write your custom code in any programming language. And I guess you did that too, Julian, but having fun with a Bash Lambda function, a PHP Lambda function, a COBOL Lambda function. As long as you can compile for Amazon Linux, because that's the OS that runs inside Lambda, you can run it in Lambda. And the way it works is you need to write a small piece of code that will take whatever event the Lambda runtime sends to your handler, pass it to your handler, run your handler, get a result back, and send that back to Lambda. And that little piece of code, it's called Bootstrap. It's like an infinite loop. While through, I will make an HTTP GET request to the Lambda service to say, hey, is there a new event for me? When there is a new event, it might be a SQS message, a SQS message, an S3 message, an API gateway call, whatever you use to invoke your Lambda function. That GET next call will return something. The event, your Bootstrap will pass the event to your handler code. The handler code apply whatever business logic is required, returns either a result or an error, and the Bootstrap sends the result or the error back to the Lambda service with an HTTP post response. And it does that in a continuous loop. So writing a custom runtime is not that complicated at high level. When you enter into the details, of course, it's a bit more complicated if you want to make it super performant and thread safe and everything. It's even a bit more complicated, but the high level understanding of what is a bootstrap is super easy.
Yeah, and it's actually super interesting when if you do want to delve into it. There are examples out there. I'll see if I can find one, like even running a custom runtime using Bash. So you can literally see the API calls. And as Seb says, there are literally only 3 things it does. Gets the next event, anything that comes in via HTTP, does your function code, and then posts either a response and an error. That's literally, in a big scheme of things, the 3 things it is. And actually, another way to think about it, which we've started talking about our docs as well, is actually talking about an OS-only runtime rather than just custom. Because the operating system is Amazon Linux, or preferably Amazon Linux 2023. That's what you should probably be doing. And we still update and patch and do everything in that operating system. So also because this is a binary, we can't, update the version of Swift or Go or Rust or, all these other compiled languages. That's up to you as part of your software development chain. But yeah, Lambda behind the scenes, even though it's custom, it is still updating the operating system for you. So yeah, it is still super useful. At least you're getting all the security updates from the operating system. And and yeah, you can figure out how the custom runtimes work because all of the actual code that runs in that Bootstrap even for all of our languages, from Java to Node to Python to Ruby, all of those, they're also all open source. So, it's actually quite, if you're interested, you can actually delve into, a decent chunk of how Lambda works and realize it's not that complicated and there isn't a huge amount of magic sauce in how the code actually runs.
No, it's especially the bash one is super easy because it's write through a curl for the get, do something, and then a curl for the post, and it fits on one single screen. It's ridiculously easy and simple. Of course, it's not very efficient if you want to run that at scale. So if you want to run a Swift function in Lambda, you just have to write your handler code in Swift. And then you have to have a bootstrap that will invoke that handler code. And of course, the good news is that you don't have to write the bootstrap, but there is an open source project called the Swift AWS Lambda Runtime. It's under the GitHub repository of AWS since a couple of weeks. It started from Apple and the community, and they asked us if we can take back that project home where it should belong, close to the other runtime. So now in AWS Labs, you have the Swift AWS Lambda runtime. So that's pretty much from my slides. Let's write our first Lambda logistic to switch to my IDE.
What I'm going to do as well is I'm just going to put a comment in the various chat channels with the that GitHub repo. If I click on the right screens, there we go, and eventually getting there. But yeah, Seb now has his IDE up on the screen as well.
So the typical IDE to develop with Swift is Xcode, the one from Apple, but Swift on the server, most of the people developing Swift on the server are not using Xcode. They are using one version of Visual Studio Code or the other. Here I'm using Kiro, and I have a terminal, and so I will build mostly from the terminal. If you're using Visual Studio Code or Kiro, there is a Swift extension that allows you to have syntax completion. You can compile, you can run your unit test. So yeah, you have first-class support for Swift inside your IDE as well. So I have a project already created with some files I will need for the demo. When you create your first Swift project, surprise, it's a print hello world. You can just compile and run this executable there, and it says hello world. Yeah, that's the first step of the demo. Yeah, we need to start with something, you know. So let's create a Lambda function. So I will create a Lambda runtime. Okay, so I have to pay attention to what I'm typing. And there is a type for that. It's called Lambda Runtime. We try to create a very simple API from the client side, from the developer side, the user side, so that it's easy to use. That class is in a package called AWS Lambda Runtime. And you see the plugin working there and telling me what to type. In the most simple form, you just pass a function, and the function is the handler. So in Swift, you can pass a function to the constructor, to the initializer of a class. So I'm going to define a function, and if you are familiar with Lambda, which I guess you are if you are attending this call, typically her handler takes 2 arguments. So here you have an event, and for this demo it will be a string, and there is a context, which is a type we do provide called Lambda context. And this is where we do something, but we are not going to type this. It's the first example, so I will start really gently, and I will just return another string which holds the event that we receive. Okay, so far so good. The function main will be asynchronous and might throw an error because now I will start that runtime, and that's an asynchronous process. So in Swift, you have to explicitly say when you're calling an asynchronous operation or a throwing operation with try. But again, this is quite similar to many other programming languages as well. So runtime dot run. And that's pretty much what I need to create my first Lambda function. Here I put that inside a struct and a static main. It's not even necessary. I can remove all that and this and have like a top level script that would run too. So if I run this, it will detect, so it will run a binary executable here on my Mac laptop. It detects that it's not running inside Lambda. So it starts a web server, a local web server on 127.0.0.1. So I can try to send event to that, so I can debug my function locally. If I start it with the IDE, I can even put breakpoints and analyze the different status of the variable and things like that. Here I started it from the command line, so I cannot jump into the call at execution time there. So let's curl. I need to pass a string, so let's give a valid string, Swift on Lambda. And then it's HTTP 170.0.0.1/7000/invoke. That's the test server working on that URL. Oops, why? I don't need that completion. Let's use a slash and not a backslash, just to be sure. And of course, it's a demo, so it's not working. Yes. I'm stupid. I type print. So of course it doesn't return anything there. It prints there on the server. That's not what I wanted to do. I wanted to return the value to the client. You see live coding after 8 p.m. It's always...
Well, Lionart at 8080 says, refreshing to see you didn't use Kira to vibe code all of this, and it's handwritten. Love it. So there we go. We are live, you see.
Okay, and now I receive the response because I return the string and not print the string there. So that's the first very simple Lambda function. And in the rest of this demo, I will do a couple of things a bit more complicated.
So it just automatically works out that you're not running in Lambda, runs a local web server that you can call directly. So that is super slick. I love that integration that there's,
out of the box.
Out of the box, yeah.
By default. So if you want to deploy that, actually that's a very nice segue to the next step, Julian. If you want to deploy that, I need to compile for Linux, because on Lambda it will run on Linux. And here you cannot see my laptop, but it's a Mac. So the way we choose to cross-compile right now is by using Docker. So I need to have Docker installed on my machine. And we use a plugin from the project. So in Swift, in the Swift package management system, a project can define plugin. Plugin are commands, for example, that will run complex scripts for you. So we created a plugin called Archive that will launch Docker, compile this for Linux inside Docker, create the binary, and zip it. So at the end, I will have a zip file that I can deploy on Lambda. The -- allow network connection is because Swift plugin runs inside a sandbox for security, and the Docker client tries to connect to the Docker daemon through local socket network connection. So I have to explicitly authorize the use of local sockets for Docker. So here the compilation is done, and at the end, I hope it's big enough. You can see that there is a zip file that has been created inside my build folder. So that's the zip file I can deploy to Lambda.
Just, we've had a question from Line Artist again, 8080. I'm not familiar with Lambda, but more familiar with Swift.
Okay.
So Lambda doesn't support Swift natively. I need to use a Docker image. It's a zip. Can I use ECR? So two things over here. This current Docker image is just to create the zip file, because Lambda runs on Amazon Linux and Seb's on a Mac, and so he needs to cross-compile. So it's literally just doing a build step for another machine. If you was SSH or something into an Amazon Linux 2023, you wouldn't need to use Docker.
I don't need to do that. And actually, the plugin is smart enough. So if you run Swift package archive on Amazon Linux, it will not use Docker. It will natively compile and create a zip file for you.
Oh, perfect. Now, there's a slight nuance over there, because you are using a zip. And I think, as Lion Artist says, you can also deploy your Lambda function from an OCI compliant Docker image. So that then would be, using a Docker image to create your Lambda function. That's a slightly different process.
That's correct. So today it's not supported by the plugin. You cannot type Swift package archive and pass something to say deploy on OCI or create OCI or something like that. But that's something we are working on. There is an open issue on the repo, and there is a branch already where we are working on an improved version of the plugin that instead of creating a zip, we'll create an OCI image with the operating system of your choice, your binary, and that OCI image you can deploy to Lambda as well.
But I suppose from now you would just create a Docker file, which would, probably a multi-stage build. It would then, use a minimal Amazon Linux, install any dependencies you need, be whatever it is, and then, just create that binary within the Docker file, and just create that bootstrap file, and you're sort of done. Then obviously you would upload it to ECR, and then create a Lambda function
from there.
to that.
Correct. Here I'm going to copy paste, sorry for that folks, but I need to create a Lambda function. That's a bit too long for me to type in front of you. So AWS Lambda create function. So I use the command line to create a Lambda function inside the region which is the closest geographically to me to minimize the latency. It's EU West 3 Paris. The name of the function, the zip file I'm going to upload. It's the zip file that has been just created. The runtime, it's Amazon Linux 2023. The zip file is statically linked, so all the Swift libraries are included. It's a big binary, but it has the only dependency it has is glibc. So you can deploy to different type of Linux. It should work. We test extensively with Amazon Linux 2 and 23. The handler is provided. We are going to use ARM64. That's important because I compile on an ARM machine, on an Apple Silicon machine. So I need a matching architecture on the Lambda side. And I'm not going to explain that, or maybe you can, but you need to give a permission to your Lambda function, at least to write its log file to CloudWatch, for example. So that's the role, the group of permission that I will assign to my Lambda function at a runtime, so that it can access CloudWatch logs for the logs. And you can see that the function has been created. It received an ARN, blah, 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 blah. There is no too much information there. So just once in this demo, I will switch to a browser to see the console and see the Lambda function in the console. And then we are going to go back to the IDE for the rest of this demo.
You are creating a Lambda function using the CLI, but you could use also CDK, you could use SAM, you could use CloudFormation. Oh dear, I thought I'd miss out on the sneeze, but
I will show that in the rest of the demo. I will.
Cool,
the next one will be deployed with SAM. So stay tuned. Let me know when you see my screen.
Oh, let me bring that up with my sneeze.
Sorry.
Out of it. Yes, your screen is up.
Okay, trying to make this a bit bigger. I don't know why. Is it large enough?
I think we can do another one or two if you can zoom in.
Yeah, I don't know why my.
Oh, there we go.
Okay.
There we go. Excellent.
So you see, I'm in the Paris region, and I have one function called myLambda that has been deployed like a minute ago. So that's the function we just create. So it expects a JSON string. Let's say Lambda in the console. And I'm really bad at typing like that. So I can invoke that function and oops. It should be like instant. Hello. Okay. Oh, maybe it's a leftover from a previous test I did. Calling invoke API network error. Ooh. That's not usual. There is nothing. The code, or we cannot see the code because it's a binary. So we will just see like there is
you will see bootstrap.
A bootstrap. It's the content of the zip file. So let's try again. Create new event, synchronous. I didn't give a name. Maybe it's that. No, it should not be. And then a valid JSON.
Maybe you need to save the. Save the test event.
Save the event first. Okay, and test. And okay, now the hello Lambda in the console. So that's the code sent back. You cannot see my code anymore, but I was just returning hello and the payload that we receive. The duration was 63 milliseconds. That's a lot. It should be much less again. But if we run it a couple of times, we should arrive at 1 or 2 millisecond execution time. Yeah, that's the normal execution time for a very simple function like that. I think 128 is the smallest memory size, Julian. Yeah. Okay. So we don't need more because you see it used only 32 megabytes of memory. So if 64 megabyte Lambda function was something, we could even use that to reduce our cost. So a very simple Lambda function like that will run typically in 1 or 2 milliseconds maximum. The called init time depends on the size of the binary. For a small function like that, it will be around 60 milliseconds, 60, which is still a bit too much in my opinion. And that's also something we are working on, is to reduce the call start time, try to understand where it's spending its time at call start. Any questions so far before we go into something more complicated? And
no, the schizophrenic web developer did say, as you brought it up, the cold start does take some milliseconds the first time. So yeah, that makes sense. I'm sure there will be other options that you can do to improve that with the runtime as well, and yeah, some other things.
Okay, and I'm back to the IDE. If you can bring the screen back there. So now we are going to do something a bit more complex. Instead of just receiving a string and returning a string, which is not really like a real word, we are going to integrate the Lambda function with other AWS services. And the most common use case for Swift on Lambda, it's API. So with an API, you will expose your Lambda function through an API gateway. So the API gateway is the HTTPS termination, the endpoint that will receive the calls from your client. It will marshal all the parameter, all the argument, and pass a JSON payload to the Lambda function. So in Lambda, I told you at the beginning, it's a strongly typed language. So if you receive a data structure, you need to have a type to match that data structure. That might be very confusing for people coming from JavaScript or for Python because it doesn't exist. But if you write in Java, for example, or in TypeScript, you are familiar with that mechanism. The different AWS services that can invoke your Lambda function have different payloads. So they are going to pass different JSON to your Lambda function. And for each of them, you need to create a type, a Swift type to support that. So the good news is that you don't need to do it. There is a library called AWS Lambda events that it's just a collection of data types for SQS, S3, API gateway, V1, V2, WebSockets, and many other, the scheduler, the event bridge, many different services that can invoke your Lambda function. If you're coding Lambda function in Rust, there is something similar. I guess in Java there is something similar as well, like a library with data structure. Based on that, the event the function will receive is not a string anymore. We are going to use an API gateway v2 request. And we cannot return a string. We are going to return an API gateway v2 response. And these have a status code. Status code will return OK. And I will pass in the body the event that I receive as input. So it's like an echo, a function. Whatever I send to the Lambda function, it will reply me with this. The compiler tells me that this call can throw, and I forgot to type try here in front of it. I can use the context to access different objects, like a logger, for example. So I can write debug hello Lambda received an event. It's an HTTP gateway, so I can manipulate the headers as well. So I can create a set of HTTP headers. Oops. And let's say I want to return something like content type equal application JSON. Here there is a compilation error because I say let is a constant in Swift, and I'm trying to change a constant. I cannot do that, so I have to type var. And there is still an error. It's because I didn't create the object there. So, and I can pass this header to my response object. So if I didn't make any mistake, this should be able to compile. So let's try Swift run. Remember, when I run Swift run, it's running locally, so it will start a local HTTP server to accept a test event, and I have a test event here. So that's the payload that the API gateway is sending when we send an event to Lambda. So I can try to invoke my local endpoint with that payload. So let's pass event.json, HTTP 127.0.0.1 invoke, and fail to connect to HTTP. Ah, yes, it's my fault. Oops, it's 7,000, not 700. And you see I receive as a response the header, the JSON that I sent. Of course, it's not nicely formatted because the generation removed the formatting. But now I'm reasonably confident that the function will work if I deploy it to Lambda. So the next thing is to Swift package archive my function. So this will trigger again the compilation on Linux inside a Docker container and create a zip file. The next step will be to deploy that zip file. But I cannot just deploy my Lambda function. I also need to deploy an API gateway and the permission so that the two can work together. So to do that, I'm going to use one of my favorite serverless services. It's called SAM. SAM is serverless application model, SAM. And the idea of SAM is that you can create your infrastructure with YAML description. So it's infrastructure as code. It's if you know CloudFormation, it's a superset of CloudFormation. It's like an easy version of CloudFormation that does a couple of things by default for you. So in a SAM template, I define a resource or a set of resource. Here I define my Lambda function. I call it API Gateway Lambda function, and I say it's a Lambda function. I give the zip file, the path to the zip file, the timeout, the handler. I don't think it's used. I put a comment saying it's ignored by the runtime because I provide the Amazon Linux 2023. So it's just the operating system provided by Lambda, and the bootstrap it's provided by the.
So that code URI is the output of the other script command that's you've just run, and it puts it in .build, blah blah blah.
I'm sorry, this.
Yeah, the code URI is the output of that other archive created.
Yeah, so at the end of the Swift package archive, there is the full path to the zip file, and I just need to give the relative path. I guess if we give the full path, it should work as well there, but that's probably
that's cool. So your SAM template can actually be the same for all your functions. Well,
yeah.
for the
as long as you use the same package name. Yeah. Architecture, super important. Environment variable, you can change the verbosity of the runtime, debug, trace, info, and the event that will trigger that Lambda function. It's an HTTP API event, so API Gateway v2 of type HTTP API. And these are just the 3 lines I need to add to my SAM template to say, hey, create an API gateway and hook the API gateway and the Lambda function together. In the output, I'm going to give the URL of the API gateway. It's an open gateway, so I mean there is no authentication there, so don't do that in real life. Only do that for demo and test. I can deploy that with the command SAM deploy. The region, I'm not going into all the details. Template file, that's the template file that you just saw. And capabilities IAM, because it needs to create IAM role for me. So it uploads the zip file, it uploads the template, and then it starts to create all the resource. You can see it creates Lambda permissions, it creates an IAM role, it creates a Lambda function, it creates an API gateway v2, and the stage and the API itself. So it's 2 different components. And then we can follow the progress there. I was hesitating to pre-deploy the function before the demo tonight. It's not that long. You see, it's already deployed, so it's available here. So at the end, because of this line here, it gives me the URL of my Lambda function. So let's try if I can call this. And yes, I receive the JSON back from the Lambda function. So we have deployed a REST API written in Swift. We've just, okay, it doesn't do too much, but we've just like 3 lines of code. We have a REST API deployed in Swift. Any questions before going to the next?
No. Well, Lionart was just asking, with ARM64, are we guaranteed to be on Graviton 4? I believe, well, I seem to remember Lambda runs on Graviton 2. So, but that is a 40% price performance kind of thing for CPU-based workloads. Check this out, see if you can do it. You could try running one on ARM64 and one on x86. To be honest, these functions are running so quickly. But yeah, it'll be interesting to see. You can use AWS Lambda Power Tuning. So this is a application that you can run multiple iterations of your Lambda function, and it can actually compare ARM and x86. So that's a way to find out what your cost performance profile is going to be between ARM and x86. But yeah, I believe it's Graviton 2.
There is a question from a schizophrenic web developer. The event is passed as a string for the previous one, but in native supported language in Lambda, it's passed as an object. So we need to parse the string itself. Yeah, that's why I pass the string surrounded with quote, because technically a string surrounded with quote is a valid JSON document. So what I did, I passed a valid JSON document. There is no brackets or curly brace, but it's still JSON. So in that Hello World example, it was a special case of JSON actually.
Yeah. Yeah, but I suppose that before, because schizophrenic web developer, thanks for the questions again. He'd written this before, or he or she had written this before. You'd actually change it from the to the API event. So also when
that's the previous example. The Hello World.
Yeah, you've also got a nice, structured, type-safe API gateway event as well.
And I prepare more example, but I'm looking at the time, so I will just show one more. And this one I will not type in front of you, so I will just copy paste a big thing there. And even with, I will go in one shot. I was planning to do that in several shots. I will explain all the code while it's deploying. So the last example I want to show you, it's a streaming Lambda function. So streaming means it doesn't return a full object directly. It returns a stream of event over time. Of course, it costs you a bit more money because the function keeps running during that time. But if you have something that produces content, like a large language model, for example, you can stream the response to the client. I will compile that and deploy. And the code is a bit more complex for that. So here I choose to create a class struct, which implements one of the protocol we do provide. And there is a handle function. Actually, that handle function is the entry point inside your Lambda. It was hidden before in my previous example. It was there, but we provide like a nice syntactic sugar on top of it so that you don't have to write that function. And that low-level handle function doesn't take a JSON object. It takes a raw byte buffer. So a byte buffer is it's a direct access to a bunch of memory in Swift, and you have a writer as a response. So you don't provide a full object, you write on a stream. So you can make multiple writes, and at the end you finish the stream, you flush the stream, and you send the end of the stream. These concepts are very popular, very normal in programming, so I'm not going to explain them too much. If you do that, the response writer has this function, write status and header. So we can return a specific header to the caller of the function. And as far as I know, there is only the JavaScript runtime that allows to do that. The Swift runtime is the only second runtime that allows to customize the HTTP header that you give to a function URL in the case of streaming or for any function URL. And there instead of returning an object, I start a loop saying from 1 to, let's say, 5. Oops, let me just deploy that at the same time so that the deployment will be done in parallel while I'm talking. And in that loop, we are going to write just number and the value of the counter. So number 1, number 2, number 3, and then we wait for 1 second. So that function will run for 5 seconds and will stream number 1, number 2, number 3. And then at the end, I write streaming complete and I close the stream. This flushes the buffer and tells Lambda that I have nothing more to stream. So this example is a bit more complex. It involves low-level handler functions that are always there, but typically they are hidden. You don't see them when you use a JSON object like we did with the API gateway or the string. But you have full access to that if you need to write more advanced Lambda function. And I need to redo it again because, silly me, I forgot to save the editor after I made change. So I'm not sure which version of the text file it took. So fortunately, the compilation and the deployment are quite quick. So here I'm using a different template. It's the streaming template, if I'm not doing any mistake. And in that streaming template, I'm not exposing the function through an API gateway. I'm exposing it through a function URL. So the how to say that, the Lambda function is directly exposed by a URL. There is a URL that allows you to invoke your Lambda function. Of course, it's a good idea to authenticate that URL so that not everybody can call that URL, and I will use IAM authentication. So I need an AWS signature with my secret key and access key, but I will show you how to do that. And I tell the URL that the response will be a stream and not a single object. So it is deployed, and that's the URL. So let's save the URL in an environment variable. Of course, if I invoke that URL now, it will tell me forbidden because I said, hey, I need authentication there. So I need to create environment variable for an access key, secret key, and things like that. I will not show you my access key, secret key. So I have a one-line command that I can use with AWS STS get session and a bit of JQ black magic that has been generated by Kiro for me to export the AWS access key, secret key, and session token. And now I can use a curl command. Do you know that curl natively is able to sign an AWS URL?
Yeah, that is super cool. And that's recent as well. It's not that long ago, I think, where that was.
I don't know. It's more than a year. More than a year. So minus user, you give your access key, secret key. You say AWS SIG v4. You give the region and the service you want to invoke, and then the security token as a header. And if I didn't do any mistake, we receive the streaming number 1, 2, 3, 4, 5. And more than that, if I call this again with -v, you saw there I send a specific header, X my custom header, streaming example, and a specific status code. That's my favorite HTTP status code. It's 418. And if you look at the RFC, the specification for the HTTP protocol, the meaning means I'm a teapot.
I did not know that.
It's part of the specification, and apparently it has been created on April 1st, 1 year. They add that, and it stays there. So it's a valid HTTP status code that says I'm a teapot. If I call the URL here, we can see here HTTP 1 418. So I have my custom status code, and I have my custom header, which is there as well, my custom header streaming example. And again, I think there is only the JavaScript runtime that allows to send a custom header, custom status code to a function URL. So I'm quite proud of that feature because it's not documented. As Julian said, I had to go to the JavaScript runtime to see how it works and to reverse engineer that and to make it work. So my point here is that, oh yes, thank you for the RFC of the I'm a teapot. So I hope I convince you that it's easy to get started with Swift and Swift on Lambda. The idea of this demo was to show you that it's quite easy to write something easy like a REST API in Swift, and it's extensible. So if you want to go deeper, to have like background task streaming, you can do that as well with the Swift Lambda Runtime. It's an open source project, so feel free to let us know your feedback, open issues, even if it is just for a question. I'm happy to help, and we are several maintainers that are going to help you. We also welcome pull requests if you have ideas of things you want to change or something is not working, which might happen as well. It's used in production. I know multiple companies that are using Swift on the server. I can give two names that are public. There are talks on YouTube available. One is the company making Things. You know, Things, it's a to-do list manager on iOS. And their backend has been migrated to Swift, and some of their backend code is running on Lambda. And the other one is a service called SongShift, for example. SongShift, they help you to migrate your playlist from one music provider to another one. So if you want to migrate from Spotify to Apple Music, you want to migrate all your playlists, and all their backend is in Swift as well. And they are extensively using Lambda and step function to make that happen.
Fantastic. I had actually forgotten, I hate to say, that custom runtimes allowed streaming. I was looking at this going, it's only Node OS only. I wrote the blog post for Node streaming. I spent ages writing all of that.
I implemented that.
And then I'm like, my word. Oh my word, crazy. Yeah, how you forget kind of things. We did have a question about async and await or task groups in Swift. Do you recommend async, await, or task groups in Swift to land on multiple parallel operations? Is Lambda only allowed a single threaded ops?
Yeah, there are multiple parts in your question. I'll try to be brief. Async, await if you need to wait for a network call to happen. So like if you call DynamoDB, for example, or any other downstream services, it will be an await call. Task group is a bit more complicated. A task group is when you want to start two tasks or multiple tasks in parallel and wait for them that one or the other finish. So it really depends what you want to do. The two are not mutually exclusive. It depends what you want to do. And for the last part, because there are three parts in your question, is Lambda only allow a single threaded ops? So that's true. You will receive only one invocation from the Lambda runtime at a time, but inside your handler, you can have all the complexity that you want. If you want to call S3, DynamoDB, and something else in parallel, and then wait for all these calls to finish and to join them, that's your decision. So yes, there is only one invocation at a time inside your code, but that code can be multi-threaded by itself.
Yeah, and that's super useful to know, and it's often useful if you're doing something like batching, or you're doing some SQS or Kinesis or high volume kind of things. You could spin up multiple threads within a Lambda function. You may need to add some more memory, which adds some proportionate CPU to be able to give you some more CPU oomph. But yeah, that is good. Okay, we do need to wrap up at Hemendex7. Thanks for joining us via Twitch. And it was quite challenging to get it to work. This looks way easier. We'll give it a try. So Seb has
Thank you.
done his job.
That's a new runtime. It's a new API. It's designed to be easier. Is there an AWS SDK port for Swift? Yes, there is the official. There are two SDK. One brought by the community, it's called Soto, and one brought by AWS, it's called the AWS SDK for Swift. Both are quite similar in design, and the one from AWS is very similar to all the other SDK that we provide. And Jeff, you also asked about Lambda Web Adapter. That's something different. Lambda Web Adapter is a layer that implements a web client that allows you to package inside your Lambda function an existing web server. So it packages all the arguments from JSON to recreate an HTTP client and to call over HTTP your Lambda server. So if you developed a Swift Vapor app or Hummingbird app, remember the two web frameworks I mentioned at the beginning, you can deploy them inside the Lambda function and use the Lambda Web Adapter, or they even build their own. Hummingbird and Vapor have their own adapter to include Vapor or Hummingbird application inside Lambda.
But yeah, also your point is true. It's a custom runtime and it does support streaming, and I should have remembered with that as well. Seb, that was marvelous. I've learned a lot about Swift. I love that it's all integrated with the Swift tool chain, that it's built into the Swift language thing that people are using. I love it when languages, I know .NET and Rust are really good with that as well. Idiomatic language things to be able to just quickly create Lambda functions using the tools you already know. And it's great to see Swift. So Seb, thanks so much. And
thank you
really appreciate all the Swift stuff. So we'll be back same place, same time next week, and we'll be talking about documenting your events and understanding your events in event-driven architectures. Bye-bye, everybody.
Cool. Bye.